Okay, so I've got a problem up here on the board. First of all, I've kept up the sum formula for tangent. Now, you can choose whether you want to have that memorized or whether you want to just derive it when you need it. You are responsible for knowing how to derive it. So even if you have it memorized, I could say start with the sum formulas for sine and cosine, use them to derive the sum formula for tangent. So do study the derivation that we worked through in the last video together. Okay. So I've got this up here for reference because we're going to be using it in this problem. What I want to do is evaluate tangent of s plus t, but rather than telling you what s and t are, I've given you just some information about them. So I'm telling you what sine of s is. It's negative 1/4, and s is in quadrant 3. For t, I'm telling you it's cosine, which is 2/3, and now t is going to be in quadrant 4. So I'm going to need to use that information to find tangent of s and tangent of t, because that's what I'm going to need to plug into the formula, just using s's and t's in place of a's and b's. Okay, so let's draw ourselves a picture. So s is in quadrant 3, okay, and we're told that sine of s is negative 1/4. So if alpha is my reference angle, I know that sine of alpha is the absolute value of that, so it's just 1/4. So I'm going to label the sides of this nifty right triangle, opposite 1, hypotenuse 4, so that I've got that, and now I can solve for the adjacent side. So I know that 1 squared plus a squared is equal to 4 squared. So 1 plus a squared equals 16. A squared is 15. Oops, 15. A would be the positive square root of 15. Positive because I am recording the actual side lengths for alpha. Again, if you prefer to label the signed side lengths for s, you could do that, in which case you'd label this as negative because we're going to the left. Okay. All right, so this is root 15. And now I can say, okay, so let's get tangent of s, two-step process. I'm in quadrant 3. In quadrant 3, tangent is positive because it's sine over cosine, and both of those are negative in quadrant 3. And then I attach to that the absolute value of the tangent of alpha, or the absolute value, which is the tangent of alpha, which would be 1 over root 15. And of course, we'll want to rationalize that by multiplying by 1 in the form of root 15 over root 15. So we're getting positive root 15 over 15. Excellent. So now let's do the same thing for t. So t is in quadrant 4. I'm going to label my reference angle alpha. I'm going to drop a perpendicular up to the x-axis. And I know that cosine of alpha is the absolute value of 2/3. So it's just 2/3. So I'll label the adjacent side 2, the hypotenuse 3, and now I want to solve for the opposite side. So 2 squared plus p squared equals 3 squared. 4 plus p squared is 9. P squared is 5. P would be positive square root of 5, because I'm solving again for a side length. Okay, so now I can say tangent of t, two-step process here. Okay, so I'm in quadrant 4, tangent's going to be negative. Okay, and then I attach to that tangent of alpha, which would be root 5 over 2. Oops, root 5 over 2. Okay, so now I'm ready to actually evaluate tangent of s plus t. I think I'm just going to copy the formula first with s replacing a and t replacing b so that I don't have to sort of multitask and remember which is which. So I'm going to say this is just tangent of s plus tangent of t all over 1 plus tan s times tan t. So I've got those values figured out. Tangent of s was root 15 over 15 plus tangent of t, so I'm adding a negative root 5 over 2, which is just subtracting root 5 over 2, all over 1 plus tangent of s, which is root 15 over 15, times tangent of t. Now, since that's negative, I think I'm just going to bump the negative to the front there and make this then root 5 over 2. Now, that's the correct answer, but that is not simplified enough. Okay, first of all, it's a complex fraction. I've got fractions within fractions. Second of all, I've got square roots in my denominator, and I haven't multiplied all of this out yet, which I also want to do. So I think the first thing I'm going to do is clear the complex fraction. What I'm going to do here is I'm going to multiply by 1 in the form of 30 over 30. What I'm doing is I'm saying my denominators are 2 and 15. I want to multiply by the smallest thing I can that will cancel out both of those. And 30 will do that. Okay. So just because this is kind of involved, I'm going to actually show all of my steps as I distribute this. So I'm going to get root 15 over 15 times 30 over 1. I'm distributing that 30, and when I'm multiplying by a fraction, I might choose to write it as a fraction by putting it over 1, minus root 5 over 2 times 30 over 1. That's distributing on the top. Now let's distribute on bottom. 30 times 1 is just going to give me a 30, minus root 15 over 15 times root 5 over 2 times 30 over 1. So now I can do a whole bunch of canceling. Okay. 15 is going to go into 30 twice. 2 is going to go into 30 15 times. So on top, I've got 2 root 15 minus 15 root 5. On bottom, I've got a 30 minus, now the 15 times 2 is 30. So the 30 cancels with both of those. And what I'm left here with is the square root of 15 times 5, which is going to be the square root of 75. Okay, so I'm still not done. Let me just come over here, clear some space, and copy how far we've gotten. So I've got 2 root 15 minus 15 root 5 over 30 minus the square root of 75. And that's what's keeping me from being fully simplified here, because A, it's a square root in the denominator, and B, I can pull out a 5. Because notice, that's just 25 times 3. So, and 25 is 5 times 5, or 5 squared. So I can say, okay, this is 2 root 15 minus 15 root 5 over 30 minus 5 root 3. So now, all of my roots are simplified. I can't pull anything out of any of those roots, but I still have a root in the denominator. And I want to get rid of that root in the denominator if I'm going to have this in simplest form. So the way to do that is I'm going to multiply by 1. And what I'm going to do is in this denominator, I'm going to keep those same two terms, 30 and 5 root 3, but I'm going to connect them with the opposite sign. So 30 plus 5 root 3. And I'm going to multiply by that same thing on top and on bottom so that I'm just multiplying by 1. Anytime we do this, where we have the same two terms but connected with the opposite sign, we call that the conjugate. And I'm going to just remind you why this works. Okay. So on bottom, I would FOIL this out. So I get 30 times 30, that's going to be 900. Outsides, that's going to be 30 times 5 root 3, so that's plus 150 root 3. Looks like I still have roots in the denominator. Then I do the insides, and I get negative 150 root 3. So those cancel. And And then when I look at the last terms, I'm getting negative 5 times 5 will give me 25. Root 3 times root 3 will give me 3. 25 times 3 gives me 75. Okay. So, because I've got the same terms with opposite sides, when I FOIL, the outsides and insides cancel, but the first terms, well, those didn't have any roots. These, I'm squaring the square root, so that lifts the radical. Okay. So I've successfully eliminated the radical from the denominator here. Okay. Now on top, I've still got to FOIL this out. So first terms will be 30 times 2 root 15 is 60 root 15. Outsides, 2 times, so I'm looking at 2 root 15 times 5 root 3. I can multiply the 2 and the 5 to get a 10. And I can multiply the root 15 and the root 3 to get a root 45. So I can multiply together the stuff that's outside the root and the stuff together that's inside the root. Insides, that's going to be minus 150 root 5. And then last terms, negative 15 times 5 is negative 75. Root 5 times root 3 is root 15. So I get negative 75 root 15. Okay, so let's see. Doesn't look like any of these roots can be, oh, that one can be simplified. I see something that I can pull out because there's a 9 in there. So if I look at 10, let's just do that up top here, 10 root 45. That's 10. 45 is 9 times 5. That's 3 times 3 times 5, so I can pull out a 3. So that's going to give me 10 times 3 root 5. And then they're still connected by multiplication, so that's 30 root 5. So this piece right here becomes 30 root 5. These other roots don't simplify, but these guys are like terms because they're both root 15s. So if I consolidate, I have 60 of them minus 75 of them. That's negative 15 copies of root 15. And then I can combine the root 5s, because that's 30 of them minus 150 of them. That's minus 120 copies of root 5. And then on bottom we have 900 minus 75. That is 875. Now I'm almost there. There's one more thing that we can do because I can reduce. Okay. Now I'm not allowed to cancel anything that's under a root with anything that's not. So I'm just looking at the stuff that's outside of the root. I can't cancel just the 15 with the 875 or just the 120 with the 875 because I can't cancel across subtraction. But I'm noticing that 5 goes into all of those things, and 5 goes into all of those things. That's the biggest thing that does. So what I can do is on top, I can factor out a 5. I say that's 5 times negative 3 root 15 minus, see, that would be 24 root 5 all over 875. Now once that 5 is connected to the rest of the top by multiplication, I'm allowed to cancel. So I can say 5 goes into 5 once. How many times does it go into 875? Let's see, 175 times. I think. I'm going to double check that. Yep. Okay. So we end up with negative 3 root 15 minus 24 root 5 all over 175. So, when I'm simplifying an expression like this, no complex fractions, no roots in the denominator, all my roots simplified, and fractions need to be in lowest terms. Now, I'm going to show you one other option for this, because some people aren't crazy about having to factor out some stuff on the top. If you're comfortable with that, fantastic. That's what we'll do. If not, let me just backtrack to where we were here, when we had negative 15 root 15 minus 120 root 5 all over 875. If you're not comfortable trying to factor out the biggest thing on top that you can, that you'll be able to cancel, your other option is you can distribute the division. So I could say this is negative 15 root 15 over 875 minus 120 root 5 over 875. Now I can actually cancel each of these fractions individually. So I would say 5 goes into 15 3 times. 5 goes in here 175. So this becomes negative 3 root 15 over 175. Minus. Here, again, 5 is actually the biggest thing that goes into the top and bottom. Sometimes when you split it, you'll be able to cancel a bigger number in one fraction than in the other. But here, 5 would go in here 24 times, and 5 would go in here 175 times, so minus 24 root 5 all over 175. That's equivalent to this. Notice if I distributed the division by 175, I'd just get this. So either version of the answer is perfectly fine, and you should just go with whichever one you're more comfortable with.